Okay, you can see it right from here. Also, I think for those who are in the Zoom, you can see my screen, right? Or you still see the whale? นะเช็คใน Zoom ได้ไหม
เห็นสไลด์แล้วครับอาจารย์
Okay, good. Thank you. Yeah. You can tell me if you want to see the whale. Okay, so this is where why we always have problem when we have only single computer. Okay, last time you ready? In the Zoom also, right? You are ready for the class, right? So on Tuesday, we discussed the first example where this is really easy. I think it's straightforward, right? And in the video, of course, I record another video. I film it and send the link to you, right? Via YouTube. If you have a chance to look at it. And in the video, I also show you how to formulate how to solve the problem using Excel, also MATLAB. Okay. And the script file, also Excel file, I uploaded. I sent to Line group, right? Yeah. Later, I will post in my course view also. Any question regarding this one? No. It's clear, right? When we have this variable, what we have, the company wants to determine how much of each product it should produce each month. Okay, so we solve the problem in order to find the x1, x2, x3, x4, right? Then the quantity, the amount of product of each product going to produce. And in order to maximize profit, so you know that because we have this keyword, in order to maximize its profit, that means, well, our objective function should be maximize of the profit or minimize negative profit. It's the same thing, right? One thing that you may confuse is this ys and yu. Okay, let's see. Ys is the number of hours of skilled labor to purchase. Also, yu is the number of hours of unskilled labor to purchase. Okay, because information in the equation, for information given that the company can purchase up to 600 hours of skilled labor, okay, and up to 650 hours of unskilled labor, okay. But this 600 and 650 are just availability, okay. The maximum, this information is set the maximum that the company can purchase of skilled labor and unskilled labor, okay. But for production plan, you don't have to, the company doesn't have to, to purchase all the 600 or 650 hours that are available each month, right? Okay, so we set the plan. Our objective function is the profit. This is straightforward. It's revenue subtract by the cost, okay? And this variable, we talk about x1 to x4. Those are the number of product, right? Number of product, yeah. And ys, yu is the number of hours of skilled labor to purchase and unskilled labor to purchase. Okay. And the other thing is, I would like to emphasize on this non-negativity constraint. You need it. You need these constraints. Okay. You need non-negativity constraint. I showed you last time that if we don't formulate these, if we don't set the non-negativity constraint, we have problem. Okay, because we allow x1 to x4 to produce as negative, right? Yeah. But in fact, we cannot do that, right? So we have to force everything must be positive or zero. Okay, so we move to the next problem. We call this type of problem as multi-period optimization problem. Okay. Later, if you are working on optimization problem, well, some of you may need multi-period optimization problem. From the name of the problem, multi-period means you are dealing with several period of time. For example, the first month, the second month, the third month, and so on. Okay, you have a period of time to find something, to solve the optimization problem. Okay, but you have multiple periods, so the problem is called multi-period. Okay, so in this case, very simple case, KW Oil has developed a dependable model to forecast future demand for oil. Okay, let's say that the company knows the demand of the oil in the future. For each of the following 4 months, the company expects the following amounts of demand for heating oil. Yeah, this first month, second month, third month, and fourth month. This is demand in liter. Okay. And at the beginning, KW Oil may purchase heating oil from a regional supplier at the current market rate, current price, market price. And the following table shows the projected price per liter at the beginning of each of these months. So at the beginning of the first month, we know the price at 0.75, okay? And assume that the company knows the price in the future. The price in the future at the beginning of the second month is this value, 0.72, okay? Also, the third month and fourth month, okay? Okay, in reality, of course, this is not deterministic, it can be probabilistic, okay? But we want to simplify it, assume that we know it exactly the value, okay? So everything becomes deterministic. All right. So KW Oil has a small storage tank on its facility. The tank can hold up to 4,000 liters of oil and currently contain 2,000 liters. What does it mean? The capacity of the tank is 4,000 liters, okay? And currently means at the beginning of the first month, in the tank, there's 2,000 liters already, okay? The company wants to know how much oil it should purchase at the beginning of each of the 4 months, such that it satisfies the projected customer demand at the minimum possible total cost. Okay. All information are given. Yeah, think about it. What information we have? We know the demand in the future. What is the demand? Demand is the amount of oil, right? That our customer, the customer want to buy. Okay, and we know the price at the beginning of each month. Okay, so what else? We know the state, I mean the amount of oil in the storage tank. Okay, before we start the program, I mean start the program. Okay, let's say currently we have 2000 liter of oil, and then we plan to purchase more oil. Okay, we can purchase right away at the beginning of the first month, or we can later purchase more oil at the beginning of the second month, third month, or the fourth month, right? So the total period is 4 months, and we have 4 periods, right? Each month is each period, and the action at each month we going to purchase oil. Okay, and so how much oil it should purchase, right? The company should purchase in order to satisfy the projected customer demand at the minimum possible total cost. So what is the objective? Yes, you want to maximize or minimize? Yes, we want to minimize the total cost. All right, so just minimize cost, but we have to map to write the cost as a function of our decision variable, right? What do we have for decision variable? Well, the amount of oil purchased at the beginning of each month. It's straightforward, right? We call it PI, okay? P1, P2, P3, P4. P1 standing for the amount of oil we purchase at the first month, the beginning of the first month, okay? To P4, P4 it's the amount of oil we purchase at the beginning of the fourth month, right? Well, we have another TI, right? We have other decision variable TI. You may have no idea what TI, because we have TI. TI is standing for T1 to, yeah, we have T1 to T4, and the amount of TI is standing for the amount of oil in the tank, in the storage tank at the beginning of I month. Okay, for example, T1 is standing for the amount of oil in the first month, in the beginning of the first month. And while T2 is standing for the amount of oil in the tank. Why do we need it? I will tell you later. This decision variable is necessary for a multi-period optimization problem, because it used to track the amount of the storage or in your storage, because you're carrying over the amount of oil from one period to another period, right? We need some variable to store such value. Okay, if you have problem with TI, if you don't understand what is TI, don't worry. Okay, I will explain you later. We will come back later. Okay, we go for objective function first. The objective function is straightforward because we want to minimize cost. So the cost for 1 liter of the oil purchased at the beginning of the first month is 0.75, right? And we're going to purchase P1. So the cost is 0.75 times with P1, okay? And the second one, 0.72, which is the cost for the second month, times with the amount of oil we purchase. We purchase P2, right? And wow, the third period, I copy this, right? 0.92. Okay. Okay, 0.92 P3 and 0.9 P4. Okay. So this is the cost for the whole 4 months, right? Can you formulate it different way? No, I cannot. It's just straightforward. I don't know how to formulate in other ways, but yeah. But if you can formulate other ways, well, you can show me. And of course, we have constraint. If you can, well, get the concept of the first 4 constraint, then you understand what is TI. Okay. The first one, customer demand in the first month. PI, what is it? P1, sorry, not PI, P1 is the amount of oil we purchase at the beginning of the first month, right? P1. And what is T1? T1 is standing for the amount of oil in the tank, right? So you purchase P1 and you have T1. Okay, summation of those number must be equal to what you sell to your customer. The customer need 5,000, right? 5,000 liter in the first month. Okay. And what about the rest? The rest become in the tank at the beginning of the second month. Okay. Assume that no loss. Okay. If you don't have loss, then material balance must be conserved. Right? Anything you get in the first month and your, well, what's in your account at the beginning of the month must be equal. Anything you spend on that month and the thing you left in your account at the end of the month, that month, right? Okay, we move to the second constraint, P2 plus T2 equal 8,000, which is demand for the second month, right? Plus T3. T3 is, yeah, the oil in the tank at the beginning of the third month. And the last one, the fourth month, P4 plus T4. Okay, summation of P4 and T4 equal 6,000. Okay. You can say that, well, why don't we put T5 here? Because we don't need anything left after the fourth month, right? But if we, well, if the company is required to store the tank with the same amount of oil at the end of the period, of course you need something, right? You need more 2,000 or something like that, yeah. But because no constraint on that, we don't need anything left in the tank, right? Okay. We have constraint on the tank capacity because the tank, the storage tank can hold up 4,000 liter at maximum, right? So we need TI must be lesser than or equals 4,000. And from the information given, the first month, we have T1, 2000, right? T1 is 2000. Okay. And the last but important is non-negativity constraint. You cannot store negative value to the tank, and you cannot purchase negative value, right? We are in the real world. We cannot buy negative value. Okay, let me conclude. So we formulate the problem as minimize the objective function. The objective function is the minimum cost, right? The cost. And our decision variable, Ti, Pi, right? Remember that we have T1 to T4, right? Ti is standing for T1, T2, T3, T4. And Pi also, we have P1 to P4. And constraint subject to P1 plus T1, okay? The equality, this equality, right? And the last one is not, oh, sorry, I forgot to explain this, because the last one, we have no constraint that we have to consume on the oil in the tank. Yeah, you can have more. So it's greater or equal. Okay. If you are forced to consume on the oil, of course, it must be equal. Okay. But if you are asked to leave some certain amount of oil at the end of the period, you have to change this to equal and plus the amount required to store the oil in the tank at the end of the period. Okay. And Ti, yeah, lesser than 4,000. T1 must be 2,000. And yeah, all Ti, Pi must be positive. Okay. Any questions? No. No questions. Then you can formulate it and solve in Excel. You did it? Yeah, very fast. You solve it already? This problem? Huh? No, not exam. Just pardon? What's the past exam? It's too fast. It's too fast. This is always example because it's very simple. Okay. You can expect more difficult. You finish it. Okay, good. And the others, what about others? You try to solve it in Excel. It's very simple. I think you. Okay, I will show you my code. I cannot read it. It's too small. Anyone, wow, those who in the Zoom, wow, please formulate it in Excel. Okay. Yes, we have KWI. Can you see it? Can you read it? Yeah, you have the same problem with me. Then you understand why I cannot read your computer. Okay, to start from clear all, right? And then Yamip clear, I explained that in my last video. Do we really need that? Clear all and clear Yamip clear? No? But sometimes, you know, well, if you have some variable remains in your in the memory, maybe, well, it's make it confused with the, in MATLAB. So always is a good practice to clear all and Yamip clear first. And set the option, because I use Gurobi, and then I force the solver to be Gurobi. And SDP-var, because we don't need integer in this case, right? We can buy just, wow, half of liters or maybe smaller. And the price, this is the, I try to increase the font. Just one moment. Can we increase the font? The font. Yes. No, but the font still doesn't change. Just one moment. I think we can do it. Maybe setting the font here. What? So code font. Okay. 18. Yes. Yeah, better. What is the? Oh, that is customer demand. Line 8 is price, right? Vector for the price, and line 9 is demand, customer demand. The objective function is price, which is a vector. This vector times with p. P is also a vector. Okay. 4 by 1. We have 4 by 1. That is vector. Okay. The matrix with 1 row or 1 column is vector. And of course, if you don't know how to write the how to write the code like this, you can write such as, well, 0.75 times with p1 in parentheses, something like that. Yes. Okay, I can write down here, so you can write this way. For example, 0.5 times with p1 if you want. I don't know. Maybe it's easier for you to understand the code. But I think it's quite long and tedious. E3, okay. But 0.9. If it makes you easier to understand it, you can write that way. Okay. Then we move to the constraint, which is a very important part. We use for loop here because we repeat. It's very similar. Constraint for 3 times, right? We're starting from P1 plus T1 must equal. And for Yamip, we need to equal, standing for equal constraint. Okay. Equality constraint must be D1 plus T1 plus 1 become T2, right? Okay. We repeat it for 3 times. And then the next one is P4 plus T4 must be greater or equal D4, which is the demand at the 4th month. And you need explanation. You can solve it in Excel though. In Excel, it's also possible to solve it. And well, try to solve it. Editor, then we run the code. Yes, you asked for the answer, right? This is the answer. 3,000, 12,000, 5,000, and 6,000. No. Because we have 2,000 in the tank, right? And we purchased 3,000, but we don't keep it in the tank because we're going to sell it to our customer, which is 5,000. And for the second month, because the price is lowest, we can expect that we purchase the oil as much as possible. Sorry. Okay. It's okay. And if you call value of this is TI, okay, T1, T2, T3, and T4. And the last line, this is objective function, okay, our cost. You can repeat it by yourself or write the code in Excel, solve the problem in Excel. And we move to the next problem. This problem, we call it assignment problem. The idea of this kind of problem is, well, you have number of jobs and you have number of people. You're going to assign job for people. Well, for example, in this case, there's a set of J jobs that need to be handled. The company has selected I employees to handle these jobs. Naturally, the skill set of these employees differ, and not all of the jobs are equally well handled by all of the employees. Okay, you know, everyone's different. Okay, so management knows the number of hours CIJ each worker is expected to take in order to complete any of the job. Okay. And the following table gives an example for a case when the J is full and I is full. Okay. We have 4 jobs. Job 1, 2, 3, 4. Okay. And we have 4 employees. If you assign the first one, the first employee, to complete the first job, he needs 3 hours. He or she needs 3 hours. Okay. Or 5 hours to complete the second job, or only 1 hour to complete the third job, or 7 hours to complete the fourth job. Okay. And the second one requires 8 hours to finish the first job, something like that. Okay. So the company wants to assign jobs to employees with the condition that each employee is assigned exactly 1 job. Okay. And the second one is each job is assigned to exactly 1 employee, to be sure that no one works on multiple jobs. Okay. And no job is handled by many people. Must be only 1 person. Okay. Most of these conditions can only be satisfied when I equal J, of course. Naturally, we want to find such an assignment that minimizes the total expected amount of time needed to process on jobs, right? Okay. Any questions? This one? Small j belongs to j. Yes, belongs to. And I belongs to, yeah, I set. Okay, so from this table, okay, we have 4 employees. We have 4 jobs. We're going to assign who is going to do any works, any jobs. Okay. What is our objective? Yes, the total time, right, required for everyone and every job. Okay. So the ultimate goal is to reduce, decrease the whole time, right? The total time required to complete all the job. Okay. So what should be our decision variables? What is the structure of our decision variables? How can we design the decision variables? Time for each employee. Wow, it's very difficult because if you write that way, it's, I don't know how to formulate the constraint. One way is I did not say that this is the only one solution, but this is one solution. Our decision variable is a matrix of ij. A similar metric like that, like this one, like this table. Okay, but our decision variable, it's each element is binary between 0 and 1. If we assign one employee, the first employee, to work on the first job, this value should be 1. If it is 0, it means, well, this guy doesn't have to work on this job. Okay, you got it? You understand the structure of the decision variable, right? Okay, so we have only one decision variable, but that one is a matrix. The size of matrix is I by j. Okay, and it contains logical variable or binary. Each element can be 0 or 1. Okay, representing true or not, right? And 1 means yes or true. 0 means no or false. Okay, then the objective function becomes c times with x. Okay, but it's going to be the element by element multiplication. Okay, we times the first element 1 1. Okay, with 1 1, c11 times with x11. Okay, and what else? Let me show you this. You see that if this element is 1, that means this guy has to complete this job, right? So it should be 1. When we times it, it becomes 3 hours, which is sensible, right? What if this element is 0? Then you times 5 with 0, it becomes 0, right? Okay. If we have xij, x, which is our decision variable, contains only 0 and 1, okay? And we times element by element with this table, it becomes the total hour required for completing all jobs. Okay, we times element by element, and then we sum up all elements together, right? Yes, this is we times element by element of all I and j, and we sum up on j and on I. Okay, we sum all elements together. Okay, then we get our objective function. What about constraint? For constraint, each employer, oh no, not employer, employee. Okay, employee is assigned exactly one job. What does it mean? We look at one single job. Imagine that this one is not, this table is not the hour required. Imagine that this one is a table of our decision variable, because it looks very similar, right? But our decision variable, this table becomes 0 or 1, right? Okay. If we look at the job 4. And we sum up all this column. Because one requirement is one job must be handled by only one person, right? So we sum this column down. It must be equal 1. Okay? Because only one person handle this job. So we can expect that in this column, there must be only one place, which is equal 1, right? So you sum all these column, it must be 1. Okay? The same apply to this column and this column and this also this column, right? If you can satisfy that constraint, that means, well, the first job will be handled by only one person. And this for this column, the second job must be handled by only one person. Okay? And the next constraint. What is the next constraint? Each job is assigned to exactly one employee. Oh, sorry, I explained you the second constraint, not the first constraint. Previously, I explained the second constraint. Each job is assigned to, one employee. Yeah, but the same. Now we sum up this row by row wise. Okay. The first person, the first employee must handle only one job. So you sum up this way, this row, it must be 1. Okay. The second employee also, you sum this way, it must be 1. Okay. And the same happened to the fourth column and fifth column. Okay, so, and very simple. This is our optimization problem. We minimize the objective function, and we have following constraint. The first one we sum by, I don't know, this one sum by J, job first, and then, well, each job, no, each person, right, for all I, and we sum up all J, will be handled by only one person, and one person work on only one job. Okay. And the next important thing is Xij. Each element of our decision variables must be 0 or 1, right? It must be binary, where 1 is standing for, that person work on that job, where 0 is otherwise, that person doesn't work on that job. Oop. Right. Okay. This. Okay. So before we go to knapsack problem, we solve this problem first, and then again we use MATLAB. That's it. Solve assignment. Oh, you cannot see my screen. Yeah. Now you can see my screen. Okay, we start from YAML clear and clear all. Then this is interesting. X equal bin var. binary variable. Okay, you learn about STP-var, right? Int-var, and this one is bin-var, this binary variables. So this bin-var, it means that our element becomes 0 or 1, just binary. Okay. And 4 by 4, okay, is a metric 4 by 4. And we set the option, we use solver Gurobi as our solver. If you use Mosaic, you can change it to Mosaic, or just comment out and let Yamip select whatever the best solver available. Okay, and then start from setting the constraint. Okay, then we follow this constraint for time. Okay, for constraint for job and for constraint for employee. Okay, and the last one, this C is a matrix of metric of what? Metric of the hour. Okay, time required for to complete each job. And we set the objective function obj sum of C dot star x. C dot star means, well, it's not C time with x, but C time with x element by element. Okay, sorry. Okay, we solved the problem. Yes, successfully solved. And then if you want to know the solution, what is x, right? X. This is the matrix of our solution. So what is some C? Now you know there's some C star x, right? C star x. C, no, this is metric, right? C is metric, x is metric. If you use C star x, means it's a matrix multiplication. Okay, metric times with metric. However, in our case, we times by element. Okay, element wise multiplication. So it should be dot star. And then we sum by row and column. Oh, พิมพ์เป็นดีอ๋อที่เด็กที่นั่งสอบอยู่เมื่อกี้มาครับโอเคขอบคุณครับ Okay, any questions? You see that? Wow, you can check that in this column. Only one appear here, right? In this column, only one here. Okay, it's good. This one also, only one here. This one, only one here, right? If you check the row wise, see that only one appear here in this row. Also, this one, only one here. This one, only one here. This one, the last one. Okay, because our metric is two dimension. If you sum it only one time, it will change from metric to vector. Okay, it's some I don't know, it's sum by row or column first, but it become vector. Okay, and once you sum it again, it becomes, yeah. Yeah, it become a single number, singular. It, what is it called? Scalar. Yeah. Okay. I hope you enjoy it. Yeah. To example. Yes. Right. And recognize P. Oh, yeah. P คืออะไร P นี่คืออะไร no P กับ P1 ไม่เหมือนกันคนละตัวกันมันพออ่านปุ๊บมันงงไง P นี่คืออะไร เพราะว่าอันเนี้ยมันคือ P1 มันไม่ใช่ P นี่อ่ะโอเคนี่ใช้ยามิดเหมือนกันป่ะใช้อะไรไม่ก็เนี่ย P คืออะไรอ่ะ P คืออะไรอ๋อไปใช้ไปใช้ เห็นไหมอ่ะ okay so wow we finished today class so we going to end the online session any question from Zoom no okay all right so wow I record the videos and then later I will share the video okay enjoy the rest of the day